Hi everyone, and welcome to this video on intersection of solids, commonly also known as interpenetration. In this, the first of a series of videos, I'm going to go through some of the basics of intersection of solids. The topic of intersection of solids is orthographic projection. It is just an extension of orthographic projection. So what I mean by that is that the purpose of most of the questions you'll encounter in this topic is to draw an elevation, a plan, and an end elevation. And there's just a few different methods that we need to be aware of and be comfortable with using to be able to accurately, neatly, and efficiently draw the full profile of when two solid objects are touching or intersecting. We'll see on SolidWorks how these objects are working. We have our square-based prism here in blue, and we have a square-based prism in yellow, and we see the way the two objects are intersecting, or as it would have been commonly known in the old course, the old technical drawing course, the interpenetration is what's happening. The yellow object, I'd suspect, is penetrating into the blue object, and it wraps around all the corners, and it touches, all of the edges touch at a specific point. And that is the challenge for us. It's to find those points where it wraps around the edges and where the points intersect or touch. Some of the common terminology here, and I'll be just, I'll probably end up going between both different ones for each. You can call it an intersection point or a pierce point. So where the edge here of this yellow prism goes in and touches the blue face, where that touches can be called an intersection point or a pierce point. So it's where the edge pierces the face, and I'll probably end up using both terms throughout the videos. So an intersection point or a pierce point, and where we have full surface. So if we just say that this is our main object that goes and presses into the blue object, where we have a full surface and the profile, it goes from our intersection point up top here to our intersection point down at the base, and it turns around. So the profile turns or it bends. So that is called a turning point or a bend point. So there's just two of the terms, or two sets of terms. So we have our intersection point or pierce point here and here, and then where the profile just changes direction, we have a turning point or a bend point. So they're the terms that we need to be comfortable with and be aware of for this topic. Now, I'm going to get started here on paper. I'm going to just get going on drawing the end elevation first of all, because the plan is already given and that is complete, except for maybe, is there hidden detail? Probably not actually. I'm sure that the top edge and the top edge and bottom edge are probably in line with each other. I'm going to go and project my end elevation, but before I do, I just want to explain that this first method that I'm going to be using is called the limits method, and it is very useful and very easy to work with, but only for basic objects. So just keeping that in mind, we get started with this drawing. I'm going to start off here by just projecting everything to my end elevation. My end elevation will end up looking like this. So where we're looking in and we can see the end of the yellow prism, and we can see that as a square there, just turned up at an angle, and then we can see our main blue prism just standing straight up from the ground, and we're looking at the leading edge here, and we can see this back face and front face. So I'll just get everything projected first, then fill in the detail. Now, what we can see next is that the extreme, the back edge and the front edge of the object. So this back edge right here and the front edge here they're just undisturbed. They're not in any way affected by the intersection. So I know that I can just heavy those two in. That's the rear edge near the vertical plane, and the front edge all the way out here. And the top of the object also isn't impeded by the second prism. Now, what I need next is I need to draw the square end on this yellow prism right here. So what are we looking for here? I'm going to start with point 1 in the back, point 2 up top, 3 at the front, and 4 down at the bottom. So what do they say? 1 is at the back of the object, 2 is up top, 2 is up top, 3 is out at the front, and 4 is at the bottom. So we'll get our numbers, just match them up. So 1 at the back here, 2 is up top, 3 out the front, and 4 down low. And in this case, it's just at an angle of 45 degrees. Now, what remains of the edge on the blue is what I want next. So we're looking at this top portion of the edge right here, and this bottom portion just here. So what's left underneath and up top. That's what I want to get next. So I'm looking for this edge, and it lines up with the other one. So ideal. And there we go, that's that object. What I'm going to do next is I'm just going to add in a little bit of colour here so that I can differentiate between the two different shapes. And there we go, that's that part done. So there's the bit of colour added there, which just helps us to differentiate the two shapes, and we see what we're dealing with a bit clearer, I think. Now, what we're trying to do next is we're trying to complete this elevation right here. And the great thing about this particular question and this style of question is that they're actually quite easy to work with. So what we're looking for next, okay, if I just change around my view here, we're looking for all of our pierce points, or our intersection points. Okay, we'll work with our intersection points first, we'll work with our turning points second. And the first one I'm going to start off with is this one out here at the front. So where the edge number 3, as I have it numbered, goes in and hits the blue face. Now, when we're dealing with simpler objects such as prisms, and prisms really are the one that are the easiest to work with here. When we're dealing with prisms, well, we can see the end of the line, okay? We know exactly where, let's just say, the edge number 3 goes in and hits the surface. And we can see that in two views. So if I just highlight this, exactly what I mean by that, I can see the point here, and I can see the point here. But if I have a point in two views, I can find it in my third view. So I can see exactly where edge 3 goes in and hits the surface here, and I can see it as a point over here. So there's nothing at all here to stop me from just completing my elevation. So take the point 3 up to elevation, and that gets me the intersection point 3 right there. I'll just put a red label on that. So I'll use red labels now for the actual wrap around and for the line of intersection. So there's the intersection point for number 3. What's next? I'm going to go up to the top of the object. I think next I'll go up there to number 2. Okay, and that is this one right here. Can I see where that edge number 2 goes in and intersects the surface? And can I see it in 2 views? Well, I have it right here. That's where number 2 hits the surface. And I have it right here where number 2 hits the surface. Once again, if you have a point in 2 views, you can find it in a 3rd view. The next challenge would be, and it's quite simple I think in this drawing, but the next challenge would be to figure out, right, 2 joins onto 3. Is it a solid line or is it a hidden line? Okay, is there something in front of it? Now we are in this position here looking in at the plan, and we're looking straight up. So I mean we just have to realize that the edge 3 is at a medium kind of a height, and the edge 2 is up top and it slopes up away from us. We could also imagine that we're standing over here and we're viewing in, and hopefully then you'll be able to realize that as you stand here and view in, the edge that goes from 3 up to 2 is visible, the edge that goes from 3 down to 4 is visible, but that's it. The rest then is going to be hidden. So 2 up to 3 is a visible edge, and then I can draw the full edge 3 right there, just like that, and I can draw the full edge 2. So that's a good start anyway. Just heavy in the edge of the object. The edge number 4 is next. I think that would be the best one maybe to move on to, and again we can see the point in 2 views, so we can see exactly where number 4 is in 2 views. So we can again just project, which is already done, and it just happens to be directly underneath 2 in this case here. There's number 4. And again, I can see that it's part of solid detail. It's right there in front of me, so I can heavy it in. Now, that gives me a good start anyway. What is next though? The next thing we need to do is this. I'm going to start up at the top now. If I just go back to my view that I just had, actually, I have just found the intersection point at point 2. I've joined it down to intersection point 3 and down to point 4. What do I need next? I'm going to go and just find this point right here, which is intersection point 1. I'm going to drop it on the sheet, but I can't just use it yet. But we will drop it on the sheet nonetheless. That is intersection point 1, where edge 1 goes in and hits the face. That is intersection point 1. Let's project. So it's already projected across. Let's project it up. And there I get point 1. So that's intersection point 1. 2 points remaining. To work with these bend points, I'd first like to start maybe by just labeling the edges. So that's the edge A on the blue prism, B, C and D, and I'll just do the same over here. A, and that's B and D in the background, and that's C, and what have we got up here? That's A and C. That's edge D, and B is the important one. And what we're looking for this time is we are looking for the place on our drawing where we can see B. Where can we see the object crossing over? Where can we see this bend point or this turning point right here, and this one underneath here? I'll also highlight them in red. Where are we looking? Well, first of all, we can see the edge, the full edge B is a point view right here. we see it as a full line up here, but we don't know where along it gets cut. But if we go over here to our end elevation, we see the bend point. Okay, right there, and one there. Okay, and I'll just call that BP1 and BP2. Bend point number 1, bend point number 2. I'm going to project them across the B elevation. Where are they? Well, they're on the edge B, which I've already labelled right there. So take the bend point, project it across. I'll drop the second one there as well, maybe. Just have it there, and we'll use it in a few moments. We have my BP1, and point 1, and we have BP2. Now the big question is, what joins the what? Because the drawing is nearly finished. So we're looking now, if I actually look back to SolidWorks for a few minutes, we are looking at the front of the object here. We went from point 3 up to point 2. It goes from point 2 then up top, and it goes to bend point 1. Now the important thing to also realize here is that, is it going to be hidden detail? And yes, it is, because we've already looked in at the front of the object and we can see the two full surfaces. So anything behind that is going to be hidden detail. So from point 2 up top down to bend point 1 is my next line I need to draw. So down there to bend point 1, very short one for hidden detail. From bend point 1, it goes down to point 1. So it wraps around the back of the object there. From bend point 1 down to point 1. From point 1, it goes down to bend point 2. Out here on the edge again, in point 2. And finally, from bend point 2, it wraps down to, what's that one? Point number 4. Bend point 2 up to number 4. Now, time to just heavy in what we can in the elevation now. That's a full continuous edge. That's a full continuous edge. B is the interesting one. It goes solid and then hidden. And found the bend point, hidden first and then solid. I'm going to add some colour here, which hopefully helps us to see what this should look like, and then we'll just finalise the question. Let's just look at SolidWorks first and see, do we get the same thing? Well, there we have the main contour, and if I just turn on my hidden detail, there we have the wraparound shown, going down to the bend point, down to point 1 in the back, bend point 2 and 4. So I'm going to add some colour here to my elevation. And there we have the finished elevation of the object. And I think it's it's always quite questionable whether we include a hidden detail edge along here or not. And I think I'm just going to drop it in for now, just as a discussion point, really. Is that a hidden detail edge or not? It's hard to know. If these were hollow objects, or objects just with a slight wall thickness, let's say, let's just say there's some sort of a guttering system and it's a hollow object. Well, if this was a second hollow object meeting into it, they were both made of sheet metal or something, then that edge certainly doesn't exist, this edge right here. Because if you had, let's just say, air movement going through, well, you can't have a solid edge there or solid surfaces to break the movement of the air. If it was just if this object was completely untouched by the other object and it wasn't in any way broken, then if the other object was just stuck onto it, well, then that would exist. So it's a questionable one. It depends on the application, but it wouldn't ever really be seen as a huge issue. If an object pushes right from one side all the way through and out the other side, then you're going to know what's cut and what's not. But that's just one thing to note before we move forward. So dealing with simple prisms, that's our first example, and we're going to move on now to some slightly harder examples. Here we have the second example, and this time we are looking at a hexagonal base prism and a square base prism, and we can see the way they intersect there. A little bit more going on this time than the last time, I suppose, but not much really. It's quite a similar style question. This time around, the top and bottom edge of the square base prism aren't going to be lining up, so there'll be a little bit more happening on the intersection line. So that's what we're going to be dealing with. I'm going to start off here in my drawing sheet by just adding a little bit of colour to the two shapes. I'll just go with somewhat of a similar colour scheme to what I have there in SOLIDWORKS. I'm going to add some colour, I'm going to label the elevation and plan there, and then I'm going to start, I'll come back on then after forwarding that much and start working on my main elevation, or my end elevation here. Now we'll start projecting over to the end elevation, so let's get going on that one. The hard detail this time is going to be all seen over here in the end elevation. The plan and elevation seem quite straightforward there. I'm going to leave all of the intersection points and all that for now. We'll just project the two main objects and nothing else. Now, what I'll do now is I'm going to just heavy in a few edges of the object, because I know that there's quite a bit of this object that's not touched in any way by the intersection of the second solid. So this back edge, the second and third here, I'm going to just draw them in heavy right up. I know that the top of the object as well remains untouched, so top of the object all the way through to here can be heavy. So let's get that much on. I'll just add some labels now as well, so I should have probably started with that, but let's just go anyway. We'll go point A, B, C, D, E and F as the main edges going down through that hexagonal prism. That gives me point edge D here. We have C and E, we have B and F, and we have A. I'm going to go with points 1 up top, 2 at the back, 3 down below, and 4 here to the left, which is 4, 1, 3 down below hidden, and 2 at the back. I project across my 1, 2, 3 and 4, and just they're all going to fall on this line right here, and then we're going to start our intersection. goes from 1 up top and 3 appears here at the bottom. 1, 2, 4, and 3. Now, what have we next? Well, we need to figure out, as we view this object across in this direction, as we view across here and here to find this view, what do we see first? Well, I think it's fairly obvious that the first one we see there is number 4. And I can see the point 4. Can I see where 4 intersects and touch the surface? Yes. So this is the limits method because I can see the limit of number 4 right there. That is intersection point 4. So I'll project that one across. Take it up. And where is it? Well, it's along number 4. 4 goes until it hits that intersection point. There's number 4. Does that make sense now? Because we need to see, where is number 4 for me? That is number 4 right there. Okay, so number 4 is this edge as it goes in and hits. If I just turn it to my end elevation, we'll just see that that makes sense. So number 4 here goes across and hits. Then we go up to number 1, maybe next up top here, where it goes and hits. Again, it intersects or pierces, and then we'll just draw the first line on this intersection. So what did I say next? Number 1. Where is it first of all? Well, number 1, it's there in plan, it's there in elevation. If you have a point in 2 views, we can easily find it in a third. There's point 1. Now, I can, I know, as I said, I know that I can see 4 and I can see 1 because if we're standing here, 4 is directly in front of us, 1 is up higher, so we can see both of those as solid lines. The first part of this profile of intersection is given right there. So that's a good start for us now. Next, where does it go? So I'm going to go from 1 to 4, and on my way down here I hit a turning point or a bend point. So that is the next important point right there. Where is it? If we just see it on SolidWorks there, well, I went from 1 down to 4, and on my way from 4 to 3, so from 4 down to 3, which is down here, I hit a turning point, which is on the edge, what, A, isn't it? Yes. So that's A right there, and it's D, of course, at the back. If I finish my labeling, that's B and C, and that's F and E. So on the edge A, I hit a bend point. So I'm going to just label that one down there as BP1, bend point 1. I take that across, and where is it? It's on the edge A. So it's on A, which is on the edge here. So bend point 1 goes across to hit A. There we have it. BP1. What's that going to be? Well, that's also going to be solid. So again, we're looking in from the front of the object here. It's just under 4, but I can still see that. Okay, it's still going to be a solid line. So 4 joins down to BP1. This is really a case of visualization and of practice, because you know, the more these you do and the better you are at visualizing them, the easier it gets to know what is hidden detail and what is solid. Okay, where do we go next? We went from 1 to 4 to BP1, so 1 to 4 to BP1, and then we wrap around the back of the object to 3. So now we're after going to behind the edge A. We've gone from 1 down to 4 down to BP1, and now we're wrapped back around to point 3. So that's the next one for us. So 3 is here in the elevation, and it joins right here in plan. there's 3, the bottom one right there, and it wraps around the back of the object and goes to intersection point 3. As I said, it wraps around the back of the object, so that must be hidden from the bend point. BP1 down to 3 is hidden right there. The edge 3 though, if that's hidden, we have to be able to see, we know that we can see that much of the edge A. The edge 3, to bring it in, goes solid as far as the line, and then it's behind it. It's at the back, so that little tiny portion there is hidden. Where do we go from 3? So we have 1, 4, BP1, 3, up to point 2. And that's all at the back of the object. We're standing here to the front, it's at the whole back of the object, so this is all going to be hidden. So number 2, where is it? Well, it's here in the elevation. It's here in the plan. And if I just turn this guy around here in SolidWorks so that we can see, we're going now from this bottom point right up to number 2 up here. So we're looking at the back of the object now, and we're projecting number 2. They seem to line up there. 4 and 2 seem to line up pretty well, or do they? Maybe, no, maybe there's just a little bit in it. There we have the intersection point, or the pierce point for number 2. What did I say it joins up to? So we're always going back here on 1, 4, BP1, 3 to 2. So 3 joins up to 2, and it's hidden detail. 3 up to 2. Where do we go from there? As we go around the perimeter of the object, it's 2 to 1, but along the way we hit this edge, so we have BP2, another bend point. That's clear here in SolidWorks as well, that as we go from, what is it, from point 2 up to point 1, it wraps around the edge right there. So it goes from 2 up to 1, but it has a bend or a turn along the way right here. Now, if you have your bend point in 2 views, you can find it in the next. BP2 marked, and where are we going? We're going from 2 to BP2 to 1. Now that's all at the back of the object still, 2 to BP2 right there, and BP2 up to 1 is also behind this tall surface here, so that has to be hidden. Finally, edge A, we can see it all the way down to here, and then it's hidden down to here. So I'm going to go solid, and then little portion of hidden. Small bit of colour to add to this. And there we have the finished end elevation. So let's just see on SolidWorks, is it in the up the same? So the end elevation right there, and if I turn on our hidden lines, so there we go, with the exact same profile or contour as it wraps around the object. The full wraparound is the line of intersection. I prefer to just call it the profile of intersection, because it's often referred to as line of intersection, but as we can see, it's 1, 2, 3, 4, 5, 6 lines in total. A profile of intersection as it wraps the whole way around the front and back of the object about edge A right there. We see the full profile of intersection. All bend points shown, the 2 bend points, and also the 4 pierced points or intersection points shown. We will wrap up this question now at that, and then we'll move on to one more. Here's our final object for our limits method for basic intersection of solids. Again, this is just really useful for prisms and for simple objects, simple shapes. But in this case here, it's just a slightly different way of approaching the question, slightly different way of posing the question, I should say. And instead of having two intersecting objects this time, you would have a regular shape cut out of the object. So it's like as if you were on SolidWorks there, you just draw your pentagon and extrude cut it all the way through the object. Now, what we are given on the drawing here is the elevation showing exactly a perfect regular pentagon cut out of the object. And the first thing I think we might need to do is to go down to the plan and complete the plan, because clearly there's a fair bit of hidden detail missing there. So that's what we'll start off with. This type of question is absolutely the same as any of the previous two that I've just done there, but again we might just have a different resulting contour. Especially the hidden detail might be different this time because there's no object there to get in the way of seeing the hidden detail. Let's just project down first of all, link our views and draw our hidden detail. And I might just add some numbering now. So we're going to just take this from my 1 up top, 2, 3, 4 and 5. Now, as we view the plan here, if I just change it on SolidWorks, we can see that all of the edges appear as hidden because they're cut through the object down below the top surface someplace, so they're all going to appear as hidden detail edges. So they're all just appearing as perfect straight lines. And that's the plan. This time I'm not going to add any colour to this because I don't think there's any need really. The plan is just one single green triangle and then all hidden detail, and the elevation is, I think it's quite obvious what's happening there. I'll add some colour after once I get towards the main elevation. The end elevation here is okay to leave it as is. I'm going to project everything now across my elevation, and while I'm here I'm just going to project the points 1 through 5 as well. Now, what I do know about this object is that although there is a pentagon cut out of this back surface, there is still a full portion of the back surface from the top all the way to the ground visible, so that's still going to just appear as one single straight edge. And the top of this object is completely untouched, so I know that I can go all the way from the left side to the right here, from the front to the back, with a solid line. That is all I can do though, because I now have to start thinking about the intersection profile. We'll just turn this guy back to three-dimensional view and we'll start seeing what do we need to see here, what do we need to do. Now the first thing is we get our viewing directions again, so to see this main elevation we will be looking from here. And the closest point to us is point number 2. So I'm going to start with point number 2. Once again, to see the elevation we're looking from here. Point number 2 comes down Can I see it on the slope surface? Right there. Okay, that is point number 2. So I'll project it. So number 2 projected up has an intersection point on the surface right there. There's number 2. I'm going to work up to number 1 next. Where is it in plan? Can I see that coming onto the slope surface in plan? There. Number 1. Next thing is, are they out here in front of me? Yes, they are. I can see them clearly that they're out in front of me. So I'm going to draw them in as a heavy line. 2 to 1. That's 1 up top to 2 down here in the middle, about a medium height. Then down to number 3 at the bottom. And they're all still on this front face out near me. Once I get past there, then I might be looking at some hidden detail. So what are we looking for next? We're looking for point 3. Can I see it in one view? Yes. Can I see it in the next view? Yes, I can. 3. There we have 3. 2 to 3 is solid. Now, the next thing is this. It goes from 3, so it goes 1 up top to 2 to 3, and then it goes to, is that a bin point? See, this is the part now where it gets a little bit confusing. We can just call that a bin point, okay? We'll just call that BP1. But it doesn't really bend. In a sense it does, but in another way it's not going to appear that way here. We'll take it for a moment that it's a bin point, it's there, that's fine. It goes from 3 to the bin point, and then it goes to 4. So let's go and find the bin point, and then find 4. First of all, I'm going to label the main triangular object A, B and C. A is here in the center, and then B is here in the left, and C on the right. Edge A, and then that is C, B. Why do I do it that way? Because C is the one close and B is the one behind. So C is first, B is second. Then point 1 is projected straight across onto A. That's BP1. Point 4 is around at the back of the object. And there it is. Point 4. Thing is, this time we don't see any hidden detail because there is no object to cover, and the bin point doesn't really have any major significance either because it's all one single horizontal line. Okay, and you'll see that in SolidWorks here in just a few moments. That's kind of a rare one, I suppose, really. Usually when you have a bin point you have a change of direction, just like we had in our previous ones. Working on ahead though, we went from 1, 2, 3, BP1, 4. I'm looking for 5 next. So point 5, where it comes out onto the surface, is there. We will project it down and hit the surface. So see where 5 hits the surface, right there is number 5. Project it up to elevation. That gives me 0.5. Now 4 and 5 join up, and you know, I'm not sure yet. Maybe if we're not quite sure yet, just join them light and leave them there for now. Is it heavy? Is it hidden? What is it? We'll see after. Okay. Keep working around my perimeter. So in this view here, and you're probably realizing at this stage this is what we do. We keep referring back to the view where one of the prisms appears as a series of edge views. So I've gone most of the way around the perimeter here, 1, 2, 3, BP1, 4, 5, and I'm going to just drop right up and grab this point along the way, which is bin point number 2, BP2. Where is it? It's on the edge A, so I'll find it on the edge A over here. BP2 on the edge A. BP2. And again, without worrying too much about what is hidden and what is not, I'm drawing 5 to BP2 to 1. So 5 up to BP2 and BP2 back to point 1. Now what we need to be able to visualize and realize here is that the object shows a hollow cutout, and that the full face of this object here has been cut right back to number 2, and as we view in from the front, number 2 is here and number 5 is to the left, so 5 is within the opening that was just made by the cut. So 4 to 5 is solid. 5 to the bin point is solid, and the bin point up to 1 is solid. So a strange question in that it's a lot of solid lines and not many hidden lines just yet anyway. What is missing though is this. At 5 we have an edge where it cuts right back through the object to the back, so I need to draw that, and it's solid until 2, and then this hidden represents the back portion of the cut from here and the back portion of the cut at 2. Same at 1. 1 cuts all the way through the object, so we need to show that. And what else have we? Well, the bin point. That would be a mistake that some people might make. Bin point doesn't cut back through the object, it's just part of the flat surface. A little bit of colour to add, but before I do, I'm just going to flick onto SolidWorks here. Let's see, does the elevation match what we have on paper? And there we have it. So it's a pretty perfect match there. Bit of colour to add, so. And there we have it. That is this drawing completely finished, and we can see the SolidWorks and the drawing are matching up pretty well there. We have our end elevation as it was given, and that end elevation shows the true shape of the cutout. It shows the true shape of the prism that would have been pressed through this object to achieve that cutout. Down in plan, of course, very little given until you turn on your hidden detail, and up in the elevation, seeing part of the inside surface cuts, but of course not making the mistake to use the bin point as a cut edge with hidden detail either. Dropping in the hidden detail there as well, and I just realized when I did that I forgot one hidden line, so SolidWorks is great for that, but it's easy to forget maybe some of these things. There's a hidden line that should have been in there as well, of course, to show that continuation of the surface going through. That is it for this first tutorial on intersection of solids, or as it may have been called before, interpenetration. I hope this has been very helpful. Just bear in mind that what you've just seen, and maybe if you've drawn along at home with these are different exercises. This method is only useful for basic objects. It is useful where we can see the end of the line or point view of the line in one view, and we can see where it hits the surface on a second view. So if it's that obvious and it's right there in front of you, then it's just projecting through, and not to really understate either how hard it can be sometimes to visualize what's happening on some of these questions. Okay, so for the basic objects and basic shapes, prisms mainly, we can use our limits method. In the next video I'm going to move on to something a little bit more difficult and a little bit more useful for a variety of other questions. Thanks very much for watching this video, and I hope it's been helpful.